In this section, I thought I would try something a little bit different with the notes because I know a lot of you guys use the View an Example feature on MATLAB to try and get through some of the assignments. So I thought maybe it would be easier if I walked you guys through some of those explanations instead of using some of the examples I have pre-made. But I'm still going to show the notes that I have typed up for any of the formulas that you need. So now we're starting section 6.4, and this will be dealing with another coordinate system where instead of measuring our locations by saying how far do you move to the right and how far do you move up, we're instead going to be using an angle from our unit circle. So maybe it'll be something like pi over 6 or pi over 4, and then we'll define a distance along that angle. The other value is going to be called an r, and that's going to describe like how far away from the origin you draw the dot. Here's what I was just describing. So there's an x distance and a y distance, and that's the way we usually have described coordinates up to this point. That's what we call a rectangular coordinate, because when you use your x and your y values, it makes a rectangle if you connect all of the sides along it. Polar coordinates instead will have an r value and a theta value. Now, the theta value is the one I actually start with, even though it's the second number in the ordered pair. So I like to identify which angle it is we're working with going around the origin. So this one, for example, looks like it's cutting the first quadrant perfectly in half. So I would expect this angle to be either 45 degrees or pi over 4. So the second number is going to be your angle, and that'll help you define what the diagonal line is pointing at, what direction it's going in. And then the first number is going to define how long that distance is before you actually draw the dot on the graph. So for example, if you have a small r value like 1, it would probably be over here, r equals 2, r equals 3, r equals 4. So you're measuring the length along the diagonal starting from the origin. To plot the points, like I said, I like to start from the angle measurement, so the theta value. It might be in degrees, it might be in radians. Then use the r value to figure out how far along that to draw the coordinate. And usually your polar graph will have lots of circles going around it. Those circles will relate to the r values. So if it says r equals 1, go to the first circle and draw the dot along it. If it says r equals 2, go to the second dot. And you'll see that on the examples in a moment. One thing I do need to point out that tricks people up sometimes is that sometimes your r value will be negative. Now, if the r value is negative, that means instead of going along the angle that was indicated, like pi over 4 in this case, it means you would actually go in the opposite direction. So just flip whatever your ray is pointing at and draw the dot however many r values out that you need to. So negative r values flip the direction of the angle for theta. So let's look at one of the examples here. So if you're using the View an Example instructions, they have an example for you as 3, 3 pi over 4. So the first thing you'll want to do is start with that theta value, the 3 pi over 4 measurement, and it could be in degree measurements, just keep that in mind. So look at your unit circle and find where 3 pi over 4 is located, and that's the one that's pointing halfway through the second quadrant. So they have the ray drawn. We now know which direction or which of the diagonal lines we're interested in using, but we don't know how far along this line to draw the dot yet. And that's where we're going to use all these tiny little circles that you see indicated around the graph. So once you have that identified, then you're going to look at the r value. If it's positive, go along that ray. If it's negative, go in the opposite direction of that ray. Now in this case, our r value was a positive 3. So that means starting from the center, you're going to go to the third circle. So it's kind of hard to see some of them since they're very tiny. Let me even zoom this in for you a bit. So that means starting from the center, you're going to go out 1, 2, 3 radius lengths, and then that's where we will be plotting our point for this specific example. And then that's it. Since this one is multiple choice, you don't even have to draw them into the graph yourself. You would just pick accordingly. So for mine, I have 5 pi over 3, which is an angle that's pointing to the bottom right. So it looks like it would probably be this one, unless I have a negative r value, but I don't. So then it's got to be going 4 values along that length. So 1, 2, 3, 4. This is the graph that matches that answer. And then you can go on to the next example. Now I'm going to jump ahead to number 4 real quick. And this one will show you one of the negative r value examples. So selecting question help again so we can see an example. This time I have negative 2, so I know I'm going to be flipping along the direction of the angle that they give me. And this time the angle is in degree measurements, but that's still not a big problem for us. Just find on your unit circle where 240 degrees is, and you should end up finding it somewhere down here in the third quadrant, pretty close to your y-axis. So now we know what ray our line is extending at. And then our next step is to notice that since our R value is a -2, we need to move in the opposite direction of the ray that was given to us. So even though the ray was going down and left, you'll see that they took that exact same diagonal line, but they flipped it across the origin, and then they went to the second circle along it to draw the coordinate. So then on the one I have here, 135 degrees, if you find that coordinate, it would be in the second quadrant. But since it's a negative value, I'm actually going to be flipping down to the fourth quadrant, and it's going to go to the fourth circle along it. Now, the only one I even see that has a dot in the fourth quadrant is this one. And just to be sure that they used the correct R value, it went 1, 2, 3, 4. So it cut my ray in half that would have been going halfway through this quadrant, flipped it down to this one, and went to the fourth circle. Okay, the next example I'm going to show is actually going to relate to a different concept. So we're going to go back to the notes for a minute here. And now we're going to talk about how to convert a coordinate from the polar form to the rectangular form. So if I give you the R and the theta value, I want you to be able to rewrite that exact same location, but by using our horizontal and vertical motion to get there instead. So tomorrow we'll go the other way around. We'll go from the X and Y values and learn how to rewrite that same location with R's and thetas, but that one's a little more complicated, so we're going to start with this direction instead. The two equations you'll need to know are that X equals R cosine of theta and Y equals R sine of theta. So basically what you'll be doing is taking the coordinate they give you and plugging those two numbers into these formulas. If you plug in R and theta, you should be able to compute cosine of that angle and then multiply it by R. And then with those same two numbers, plug them into this second formula, compute sine of theta, multiply it by R, and that will give you your two X and Y values. So then you'll just be able to make your coordinate at the two answers that you get from it. So let's look at our examples for this as well. I'm going to jump ahead to number 14. Now they drew the dot on the graph for us, so you can even visualize what's happening here. Basically, we just want to know how far are we measuring to the right and up, instead of by determining that along the pi/6 angle, they're going 5 radius lengths out. But let's look at the example they gave us. So we have a coordinate 7, 2 pi/3. And again, they've drawn the location, but it's not really necessary for these. What matters is we need to know that R is 7 and theta is 2 pi/3. So we're going to plug them into these two equations, R cosine of theta and R sine of theta. For R cosine of theta, plugging in looks like this. Now we have 7 times cosine of 2 pi/3. Since 2 pi/3 is an angle that's even on our unit circle, we can do this without our calculators. We just need to look at the x coordinate on our unit circle. And cosine of 2 pi/3 is actually equal to -1/2. So then if you multiply -1/2 times 7, we now know that the x value is -7/2. We can't reduce that anymore. So for our final answer, we're just taking the two values we found, the x value and the y value, and now we have the ordered pair that describes this exact same location, but in a different system. Instead of saying at this angle, go 7 units along the diagonal, we're saying go this far left or right and go this far up or down. So that is the exact same coordinate just in our rectangular coordinate system. And that's all for the notes. Thank you guys.